Hello, I have question 4 here. It says the opposite graph shows the variation of terminal potential difference, okay, across a combination of 3 cells in series to a resistor versus the electric current. Okay, so I have the V and I, the variation of V and I inside a combination of cells, which are 3. Okay, the first question says that calculate the electromotive force of each cell. Okay, so since they are connected in series, okay, I will have 3 cells connected in series. Each one of them will have an electromotive force. Here I have E, here I have E, here I have E. Okay, so I want the electromotive force. I know that the electromotive force is actually the point of intercept with the voltage axis. This is the point of intercept. You see the line across the voltage axis at this point with the 6 volts. So I can say that the total electromotive force, which is going to be 3E, because I add them, is going to be 6 volts, which means that the electromotive force of each cell is actually 6/3, which is 2 volt. So please pay attention to the question. He is asking for each cell, okay, for each one. Now in B, they want the internal resistance again for each cell, okay, for each cell. The 3 cells are connected in series, right? So the total resistance is going to be the sum of them. So I know from before, let me remind you that internal resistance is actually minus the gradient. Okay, and since I have like 3 cells that are here in the graph, represented in the graph, is going to be 3R, which is equal to minus M. M is the gradient or the slope. I know that M equals, I have y2 minus y1 down here, x2 minus x1. Okay, I'm going to choose 2 points. I'm going to choose this point here. It's the first one. Let me write the x and y for it. Okay, here is going to be the x for this point is 0. The y for this point is actually 6. Okay, the second point, I'm going to choose this one here. This is the second point. I'll write the x and y for it. The x for this is 1, okay, and the y for it is 3. Okay, so now I have x1, x2, y1, and y2. So here we complete is going to be y2 is 3 minus y1 is 6 down, x2 is 1 minus x1 is 0. Okay, so it's going to be minus 3. This is the radius. So I go back here, the 3R equals to minus the minus 3, which is going to be 3. So the total internal resistance is 3. So if I want to find the internal resistance for each one, is going to be 3/3, which is 1 ohm. Okay, this is the internal resistance for each cell. Okay, now the part C in the question says, what is the current I that makes the power dissipated in the circuit maximum? So I need the maximum power. We know that I will have a maximum power only in one case, when the external resistance equal to the internal. Which internal? It's the total internal. Why total internal? Because they say in the circuit, so the whole circuit. Okay, and this means that the current, which I know it from before, it is electromotive force over external plus internal. In this case is going to be RT, okay, which is total, okay, equals to E over internal plus internal. Again, it's the total and the total, which means I'll write here I equals electromotive force, of course the total electromotive force. Also here is going to be the total electromotive force because I have three cells connected in series, okay, 2 are total, okay. This equals to 6, the electromotive force is 6 over 2 multiple 3. 3 is the total internal resistance, okay. So the current will be 1 ampere. So this is the value of the current that will give me a maximum power. Okay, guys? Okay, now I change the color, okay, and I read D. When the current is 2 ampere and the volt, the V, which is the terminal voltage, is 0, what do we call this circuit? Well, of course here when I have the terminal voltage 0, the terminal voltage V is going to be 0 volt. This means that the external resistance or the load is actually 0 ohm. In this case I have no load, no external resistance, okay. Let's make sure, let me here convince you, because I know that E equals I R, let me sorry, it's I equal I over R plus plus R. Okay, I'm sorry, it's my mistake, blah blah blah. Okay, I come here E, okay, equals how much is the E? Is 6. If we put this one 0 plus the R here, it is 3, I will have 2 ampere. So this is the case they are asking me about, okay. When I put the external 0, I will have a current of 2 ampere. In this case they are asking me, what do we call this circuit? We call it a short circuit. It's a short circuit, okay. I hope it's clear. So again I will repeat, the external voltage or the terminal potential difference is 0. It means that the load is 0, and this we call it short circuit, okay. Now they want me to draw, in part E, they want me to draw the graph of variation of the power and the load resistance, okay. We just agreed before here, I will have a maximum power when the external or the load equals to the internal resistance, okay. I will have a variation like this, okay. I hope that I succeed in drawing it the first time. Okay, it goes from the 0, it goes to the high value, and then it goes down here, okay. At this point I will have a P maximum, so at this point, okay. So I will have here, let me go down here, at this point I will have a value of the load, which is going to be the internal resistance. Of course here it's total, okay. Again, why total? Because I have 3 cells connected in series. So this is the variation, okay, of the power with the load, okay. In general, This is the formula, the graph. I hope it's clear, guys. If you have any question, please leave it in the comments below. See you. Have a nice day. Bye bye.